Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Hortonworks, Teradata, and Informatica for sponsoring today's event. All three companies are wonderful supporters of the Data Science Central community, and we are honored to have them sponsoring our webinar today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Cisco, Tableau, MapR, Splunk, and Platform, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to take a look as they do provide some very useful information. Today's webinar is entitled Hadoop 2.0, Yarn to Further Optimize Data Processing. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be approximately 1 hour long. We have three panelists that I'll introduce to all of you in just a few moments. We should have about 10 to 15 minutes for Q&A following the presentation, and this event is being taped and will be made available later on this afternoon for on-demand viewing. I'd also like to encourage our attendees to ask questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's webinar. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce our panelists today, John Kreisa of Hortonworks, MapReduce of Teradata, and John Haddad of Informatica. John Kreisa is the VP of Strategic Marketing at Hortonworks and a veteran from the enterprise marketing industry. He has worked on products at every level of the IT stack, from the depths of storage to the insight of business intelligence and analytics. MapReduce is the director of Teradata Product Marketing and is responsible for Teradata software and hardware products, including the Teradata Database, Teradata Platform Family, Teradata Unity, Tools, and Utilities, and in-database analytics. And Matt is also responsible for creating and maintaining tools for calculating Teradata's total cost of ownership. And John Haddad is the Senior Director of Big Data Product Marketing at Informatica. He has over 25 years' experience developing and marketing enterprise applications. He advises organizations on big data best practices from a management and technology perspective. John graduated from UC Berkeley with an AB degree in applied mathematics. Welcome to you all, and thanks for being with us this morning. We're looking forward to your presentation. Data is exponentially increasing in both types and volumes, creating opportunities for businesses. To fully realize the potential of this new data, analysts recommend the shift from a single platform to a data ecosystem. For this to take place, multiple systems are needed to exploit the variety and volume of data sources. A flexible data repository, such as a data lake, is needed to store this data. Apache Hadoop 2 enables a true data lake architecture. The introduction of Yarn allows for a pluggable framework that enables new data access patterns in addition to MapReduce. An intelligent data management layer is now needed to manage metadata and usage patterns, as well as track consumption across these various data platforms. So John, with that, I'm going to let you take over, and you can begin your presentation as soon as you're ready to go.
Thanks very much, Tim, and good morning, good afternoon to everybody. I would like to also thank my co-presenters, Ahmad and John, for working with me today on this presentation. Very happy that everybody could join us. So I'd like to build on what Tim started off with around growth and big data, and that really is the why for Hadoop and for data lake-like architectures that we're going to talk about today, and how those are enabled by a Yarn-based architecture. But let's start with the why. And that really goes back to the growth in data that organizations are experiencing. We've got some data here from leading industry analyst groups, Gartner, and from IDC. And really that just puts some meaning behind and some numbers behind the actual big data explosion that everybody has heard about and also might be experiencing yourself in your organization. Now, let's start with the information that's at the top there from IDC. Importantly, data is set to continue to grow at a really tremendous rate. If you look at the 50x data growth number between 2010 and 2020, we're about halfway along that journey, heading down towards the growth. And you may be, as I said, experiencing this growth within your organization. But in that data, what kind of data is growing? I think it's important to really focus on that. 85% of the data growth is coming from new types of data. And what we mean by that is data types that organizations now newly want to exploit. Certainly things like weblogs and such aren't new, but what is new is the idea that there is real value in capturing and analyzing that data alongside of the other traditional sources. So it's really new sources of data, and they're growing very, very fast for a variety of reasons. Now, 2.8 zettabytes of data was created or replicated in 2012, but that's really going to continue to explode. If you look at the overall digital universe, according to IDC, that's set to be 40 zettabytes by 2020. So really just astounding amounts of data. A zettabyte, in case you weren't familiar, is 1 billion terabytes. So there's a lot of data that's being created. And importantly, one of the key drivers in all of that data growth is in the machine-generated data. And that specifically is set to grow more than 15 times by 2020. So we're going to see this data continue to grow. A lot of it's going to be created by machines coming off of devices, whether it's a smart refrigerator in your house or the jet engine that is flying on the plane that you may be going to your next destination on, or from the power grid that's delivering power to your home or business. That machine-generated data is one of the key drivers. Now, that's important for us, but really what does it mean? And if you look at what Gartner has done, they've kind of taken a little bit different angle in terms of analyzing the data. And one of the things they've said is about 65% of the new analytic applications that are going to be created will have Hadoop at the core. So Hadoop has really cemented itself at the core of this architecture, particularly with some of the more recent innovations that have happened in that core platform. So 65% of new apps will have Hadoop at the core, and that includes integrating them with the existing technology, some of which are here today. And a lot of the relational and traditional systems will be Hadoop enabled, meaning they'll be fully interoperable with those, and a lot of that work is going on with our partners like Teradata and Informatica, and you'll hear more from Imad and John in just a moment. And then what's really probably gets to the core of why to exploit this data is there's a real competitive advantage to be gained. And according to Gartner, it's about 20% is the percentage by which organizations who leverage this modern data will be able to outperform their peers. So a real significant and large performance advantage can be gained by taking advantage of this big data if you can get the right tools in place, if you can get the right skills in place. So that's kind of a key driver for why we're looking at this. Now, if we look at the existing systems that are out there today, that new data type, that growth in new data really puts a lot of pressure on those existing systems, simply because either financial pressure or technological pressure. In many cases, it wasn't the design factor for how those systems were created. They create a tremendous amount of value around the types of data they were developed for. But as you start to get to these newer types of data that organizations are looking to capture, that really does start to put significant amount of pressure on those existing systems. So really what that requires is a new way of looking at data. It's a modernized data architecture. And that really comes with adding Hadoop into that overall architecture. So just modifying our fairly simple diagram, we get a picture of what that looks like generically, to have Hadoop alongside of existing data management systems, still driving applications, connecting to my existing applications, but also driving net new applications. And overall, really this explosion we're seeing in terms of usage of Hadoop that's being driven by and complementing the existing technologies today is really from that Yarn operating system, the Yarn architecture. And that is enabling a wide variety of workloads to operate on top of a single common pool of data that's stored in the Hadoop distributed file system. So that gives you the basis for a data lake-like deployment, because I can have multiple workloads which encompass transformational workloads and other kinds of data processing workloads integrated alongside of my data warehouse and integrated with my transformation tools and ETL tools. to really enable that broad usage of that data and gives me that batch, interactive, and real-time ability to interact with it alongside of my existing tools as integrated with my existing tools. And that's how Yarn is really driving that overall data lake architecture. And again, this is something that you'll hear more from Ahmad and John as they go forward. But this is really at the core of really helping companies leverage these new data sources and drive the enterprise forward and allow them to take advantage and really get that 20% performance advantage that Gartner talks about. So just in terms of how Hadoop is being adopted within these organizations, the way that we see it from Hortonworks' perspective, and I think this is echoed and shared by my partners today, Hadoop starts small in scale and small in scope. And what we typically see is organizations who are successful start with a single type of data that they want to exploit, and it's driven by a line of business needs. So it might be somebody in marketing or in operations or in finance or some area that wants to take advantage of one of the types of data, and they'll build a new analytic application on top of that which will encompass other types of data together. So it's driven by line of business. Now it's starting small in scope, meaning it's usually just 20 to 40 nodes in size, that cluster, and it's really only has that one application. But they can grow quickly from there. And let's look at the kinds of data first that are being captured. So there's social media data, right? How is somebody feeling about your products or service? It can be expressed in web comment systems and rating systems and blogs, tweets, all the different ways that somebody might express their opinion about your product and service. Clickstream data, which is how are you interacting with your customers? Most businesses today interact with their customers at least in part, if not fully, through the web and mobile devices. And capturing that data allows you to get more insight into how you can better service those customers. Sensor machine data, we talked a lot about that already. I won't spend time just to say the machine-generated data is going to grow 15x. Geographic data, that means where is somebody consuming your product or service? How is your fleet of delivery vehicles being deployed? Is it the most efficient way? Where are geographically the weak points in your distribution system? For example, server logs, so process failures in manufacturing systems and other systems that are working within your and driving your operations. And then finally, unstructured data, which I'll say is a catch-all for just raw text data, video data that might come off of surveillance cameras and other systems, photographs, audio data, really any kind of unstructured data or semi-structured data. Some would say there's always some kind of structure there. And then finally, Hadoop is also being used for keeping existing data around longer. No longer do you have to necessarily shift it off to an archive system where it's not available. Hadoop gives you that online archive where it's still queryable, completely integrated with your data warehouse, for example, via unified data architecture that we have with Teradata and that Informatica plays alongside. So lots of ways to unlock these new types of data in the existing architectures that you have, but these are the kinds of data they're looking to exploit. And what you can do actually, and I talked about the fact that when they start small, it's around a particular business use case. Here you can actually map the existing applications to specific types of data. And what we've got is just examples taken from the hundreds of customers and implementations that we have at Hortonworks across these different industries. Like any kind of new platform-based technology, it really has broad applicability, and you can see these samples taken from a variety of industries. So depending on what industry you're joining from, you can very likely see a kind of application. And what we see are, these often start with just involve one or two types of data. So for example, financial services evaluating trade risk come right out of the server log. That application built on Hadoop comes right out of server log data, or new account risk screens coming out of a combination of text data and server log data. And you can take those examples and look at them across the board for these individual applications. And once a company gets one application up and running, starts to get the skills and expertise, then they start to think about how can they expand the use of Hadoop. And that really talks to how we start to get to our data lake deployment. So after starting small in scope, they grow out in one of two ways. One of those ways is scale, which is just I'm going to capture more of the same kind of data and maybe enable more users to take advantage of that data, be it through the easy-to-use interfaces that I have with Informatica, for example, in order to Big Data Edition, in order to take advantage of that data, or I'm building new kinds of applications which involve new workloads and capturing just net new data. So now I've got multiple applications, some which might be batch, some which might be interactive, and I'm doing some kind of data transformation or streaming data capture if it's in the real-time range, all landing that inside of HDFS. That ultimately ends up pointing towards a data lake deployment where I'm moving data back and forth, I'm analyzing it, but it's all enabled by that yarn architecture, the ability to have data run and have multiple processes interact and interoperate with that data. So that's a yarn-driven modern data architecture, and that leads to the more mature data lake deployments. That's really the journey that you ultimately get to. But we always recommend starting small and thinking small and getting the skills and expertise, utilizing some of the tools and interactions that you have with some of the existing infrastructures like Teradata and Informatica, but then building out as you develop that expertise. And that leads you ultimately to the modern data architecture. And of course, with Hadoop and with Yarn, you want to integrate deeply with those existing technologies. Of course, today, very closely working with our partners, Teradata and Informatica, but we interface and interact with all of the tools that you need within your organization to take advantage to analyze and process, report on, and just get additional insight out of that data. So that's a little bit of background about why Hadoop, what it means, what a Yarn architecture, how that drives the adoption and moves organizations towards a data lake. So now I'd like to turn it over to Imad to tell you a little bit about Teradata and how Teradata plays within the data lake architecture.
Thanks, John. Hello, everyone. Glad to be with you here today. So John talked about some really interesting points. And there's some changes going on in the industry. There's changes going on in the landscape. He talked about the growth and showed some numbers from IDC and other analyst firms. The amount of data growth is just unprecedented. We've seen over the years growth in data, but the rate of growth that we're seeing now has never been seen before. And it's not just the volume of data growth, but what we're seeing is that there's a growth in the sources of data. Machine-generated data, anywhere from commercial companies to personal devices like mobile telephones and those things. New sources of data that are coming up, machine-generated data, social data, and then it gives rise also to new data types. So not only do we have the structured data that we're all familiar with, but new types of semi-structured data that are coming in and bring new challenges with them. And with that, we've seen a growth in the types of analytic technologies available, Hadoop being the major one in the industry today for open source analytics, for new types of analytics, custom-written analytics. So there's this growth on multiple dimensions, growth in data, growth in data sources, new data types, and new tools that are coming around. And so the question becomes, well, how do you deal with all of these things? You need an architecture that can scale and handle all of these. When you look at Gartner, they recommend what they call a logical data warehouse. And this is a shift from a single platform that can do everything to an ecosystem that is a combination of technologies all working together to solve a set of problems. And in this case, each one bringing its unique values. And when you look at this, you say, okay, going from a single platform to multiple platforms, didn't we do that already in the 1990s and data marts and all of that? Well, there's a difference this time. Back in the 90s with data marts, the difference there was companies employed the same technology, mostly the relational database, with several instances of it. So you took the same technology and just replicated it multiple times for different departments and all. And that was, looking back, I think not necessarily a good thing. But what's different today is that the idea of this logical data warehouse is not saying that. The logical data warehouse is saying, take tools and technologies that are different. Each one has different skills, different file systems, different algorithms, different types of analytics that they run, each bringing its own skills and talents to the game, and you put them all together, and the combined effort of all of these becomes the logical data warehouse. So you see on the chart there are relational databases, but you also see both row and column stores, complex processing engines, in-memory databases, Hadoop and HDFS. So it's a combination of different types of tools, each with their own capabilities coming together to solve a different problem. And why can this be done today? What's different? If we go back to the things that John said about the growth and the new data types and all these things, things that have changed today is that the economics have changed. So why can you do all these things? Well, the economics have changed in terms of processing power as much more affordable. You can get lots of processing power for a relatively inexpensive price. The amount of storage, the capacities of storage have just grown considerably. So the cost per terabyte, the cost per data storage has gone way down. The availability of technology, open source technology has certainly contributed to that, but also commercial vendor-based solutions, and the combination of those two create really powerful combinations. And then even the delivery methods. On-premises continues to be strong, but even things like cloud delivery. So all of these together show that the economics have changed in the ability to handle all the growth in data and data types and all of these things. So on this slide, what we're seeing, this is Teradata's view of the Gartner's logical data warehouse. We call it the unified data architecture. And there's a lot going on the slide, but let me just kind of point out a few things. We have on one side here, we have all the different sources of data, traditional sources and new data sources. You have the consumption on the right there with different types of users and different types of applications or tools that they access with. And then three main categories in here: data platform, data warehouse, and discovery platform. We did a lot of research and discussion with our customers, talking about what are your needs. Let's not just build tools and put them out there. What are your needs, and then we'll build tools to fit those. And starting with the orange, one of the obvious needs that existed out there in the customer base is that there is this need for cleansed, agreed upon data that the organization makes decisions on. So single version of the truth, single repository, everyone reading from the same set of data, high availability, service level agreements, that kind of thing. And when we look at that, that's where the data warehouse has played. And so there is a way to meet the customer's needs with something like that. And then going here to the left, this idea of a data platform. So what we heard from customers is, I need a place to store this massive amount of data that I'm getting from the machine data, the sensors, the social data, all of this things, the data that's coming in. I need a way to store it. I need some simple ways that I can access it and manipulate the data. And we look at that, we say that's a data platform. And we'll see that becomes what we're talking about here is a data lake, this place to store all this data. And then the third category is we need some way for discovery, where we can look at different data types, combine different data types with different types of technologies and different algorithms, bring them together and do some advanced analysis. So we see that there are the different capabilities here that are needed. If we take that and we start mapping it to the different technologies, we'll see here that how our three companies come together to solve business problems. Informatica is a leader in data acquisition, cleansing, transformations, data management, and they come in and they work within the architecture with all the platforms, with the data warehouse, the data platform, which we'll say is the data lake and the discovery platform. And don't let the arrows here confuse or the picture or anything. The Informatica tools are very robust and allow push-down processing into these different technologies, and also you can use the Informatica servers themselves to do all the transformations and data sourcing and all. And then in this data platform area, which is really it becomes the data lake, is Hortonworks, which is we believe the leader in Hadoop technologies, being the closest to the open source community and staying true to that. And so Informatica is a great partner for Teradata, so is Hortonworks. We actually have a Hadoop appliance which has the Hortonworks product inside there, again, because it's the closest to the open source as you can get. And then for the data warehouse and the discovery platform, the Teradata solutions are on the Teradata database and the Aster database. So this is how we see the three companies coming together to address the needs that our customers told us that they have and fitting together in a cohesive way to solve the different problems. And so if we focus a little bit here in the blue area around this data platform, which really becomes the data lake, I think if you were to look out in the market for definitions of data lake, you'd get lots of different answers, lots of different opinions. But this is one of the ones that we look at here, and that is that the data lake is a single source of that raw, historical, real-time operational data. So you bring lots of data in and store it, and you may not have an immediate need for it, for accessing it, you may, but it's a place where all your operational systems can bring their data, put them in there for access from other analytic tools and other platforms, right? So it becomes your central source there. And the ability to cost effectively explore the data, and you see the words here, unknown, underappreciated, or unrecognized value, especially when you look at machine-generated data like sensors or even weblogs. The value of that data may not be immediately apparent to you, but you need to be able to store this data. You want to have it there and available in an accessible way when the time comes that you need it. And actually, in a few slides, we'll show you an example of how that comes together to be able to access it and use it when you need to. And reduction of line of business specific sourcing of data. Rather than have every business unit or every department build their own data lake or the version of the data lake, we all advocate, our three companies advocate, that a data lake is a shared environment where all the lines of business put their data in there, and that really reduces costs, reduces any discrepancies in the data. Everyone's putting their data into the same place. And of course, when all that data is co-located, you can do some analytics, you can do some advanced analytics, customer analytics, data transformations, all of those on the fly. And there's lots of tools out there to do that. So all of you have been in the market and in the industry for a long time, I'm sure. You've seen technologies come and go, terms come and go. The data lake, whether it changes terms or not, I think we'd all agree the concept of a data lake and what it brings to the table is pretty much here to stay. I think this is a long-term kind of need that companies have, and we'll see it continue on into the future. So we're talking about bringing this data into a data lake and using it when you need to. It brings up the question of, well, how do you access that data? How do you look at it in terms of data integration? Well, there are two methods that are used in the industry for data integration. One of those is the schema on write, and the other is the schema on read, which is a more evolving, newer way for data. The schema on write is what we've all been working with for the last couple decades, and that is predefining data, determining the schema early on. And so this is what you use when the data is well understood, the application developers and the data warehouse architects and all work together, the ETL folks all work together to make changes in unison, define the data, define the structure, and then implement it all at once. There's some benefits here, lots of efficiency when it comes to storing the data in that format. Of course, you can keep relational integrity because you know what data to expect and how it all relates to each other. An evolving method here is what we call schema on read, and that is keeping the data in its raw form and then creating that schema at the time you access it. And this is great when data is not very well understood, when it's dynamic, when it's changing. So you have a file from the same source that comes in, and sometimes it has 5 data entities in there for attributes, and sometimes it has 20. It's variable and dynamic, and the rate of arrival is different. And so this is great for those types of environment. And because you expect that the data is going to be dynamic and changing, it changes the way internal groups within a company work together. So the application developers and the data architects and everything, there's a reduced need for coordination in there in the application design process. And the data is human readable as well because it's self-defining. Which of these is better? The answer is neither. They just have different capabilities and different times to use it. You look at a data warehouse, that's typically mostly been on the schema on write area, but has been reaching into the schema on read with new data types. And the same thing for a data lake, which has been traditionally schema on read, and now evolving to have more schema with the advancements like HCatalog, allow for defining the schema early on here. So with that, there's also then been a change. If you put that together, a change in some of the approach. In the previous way of doing things, when you just predefine the schema up front, the classic method is business users determine the questions they want to ask. They work with IT. IT determines what are the pieces of data I need to make that help the business answer their question. They capture those pieces and only those pieces. Versus the capture everything in case it's needed is flipping that around, which is let's capture everything, and then as business users explore the data and define their applications, we pull from that data source. All the data is available to us on demand, and we can define the data we need. So a lot of flexibility in this approach, and again, that's facilitated with the data lake capability. So let's look at 2 examples quickly here on how the technology from our 3 companies can come together and solve problems, real business problems. In this case, we're looking at automobile sensor data. And what we're showing here is that in the Hadoop world, we're storing sensor data. This is the machine-generated data. Tons and tons of temperature sensor data in this case. On its own, may have little to no known business value. In the warehouse, you would expect the business type of data, vehicle identification number, service records, warranty, all of those types of things. Well, let's say you discover that there's a bad battery lot in there. If you didn't have access to the actual sensors, temperature readings of every single sensor, then what do? You would have to go out and replace every car with that bad battery lot and make a major recall. Whereas if you have access to the temperature sensor data, you can combine the data within Hadoop here and the data warehouse to look at which cars have that bad battery lot but are still within tolerance. They're still within this green area, so maybe you don't replace the batteries on those cars, whereas others are at the high end. They're kind of in the dangerous range where you would take action and actually repair those cars. So it gives you a fine-grained access ability to make decisions. And then another last use case here is customer value. So with the data warehouse, what most companies want to do is figure out who are their high-value customers. Well, now you could take that data, send it over to Hadoop, do a sentiment analysis on social data. How are my customers feeling about me? Are they happy? Are they unhappy? And then once you know how your high-value customers are feeling about you, do a graph analysis and determine who are they related to. Are they related in their sphere of social influence, other high-value customers, and how far does that extend? And so now you can determine the value of your customers based on their sphere of social influence, and that's a very advanced thing to do. So bringing the technologies of three companies together here can really help you do some advanced analysis. So I'm going to turn it over here to John Haddad to continue the discussion here from Informatica.
Thank you, Ahmad, and thank you, John, for running through the premise for big data, the business drivers, the logical data warehouse. And now what I'd like to kind of zero in is how do you optimize the data pipelines using a modern data architecture? What does that look like? What do the use cases look like? What's the process and architecture look like? And why is Yarn and 2.0 important for that? So it begins with this, what I'll call a big data journey. In fact, John Kreise alluded to this being a journey also. And the first step is to really prioritize your big data initiatives and big data use cases. And both John and Ahmad had alluded to several, fraud detection, lowering total cost of care in healthcare, also the ability to do predictive maintenance, to reduce warranty costs, social media in order to understand sentiment. There's a whole slew of different big data business initiatives. And the business is what's really driving that, right? And this is what defines the journey. But in order to get started with this journey, it often begins with IT basically getting their house in order and taking advantage of some of these new technologies like Hadoop to optimize their information management infrastructure so they can build out a data lake that complements their existing infrastructure, right? The data warehouse appliances, their MDM systems, all their relational and operational systems is really key. And so they, as John had pointed out, they often start with one type of data and start to extract value out of that. And then they start to expand and build out what is often referred to as this data lake. We call it a managed data lake. Some companies call it a data reservoir, an analytics cloud, a logical data warehouse, as we just saw, is another way of looking at that. And the modern data architecture supports that. Why is Yarn and Hadoop 2.0 so important for this? Because as you go from that first data warehouse optimization project and start to expand it across the enterprise for multiple use cases and business initiatives, you have more workloads, more projects. And so that these projects and workloads don't come in contention with each other, it's important for Yarn to help manage the resources appropriately and optimize the workloads appropriately so that you're not misusing the investment that you added, so that everything is being utilized and optimized for the greatest efficiency. And then finally, where this all leads to is, well, what's the use of a data lake if I'm not really extracting the value, if I'm not integrating and analyzing the data and actually delivering the insights so that the business users and even the customers can take appropriate action. And one very good example, one common example of this is real-time customer analytics. So what I'd like to do to kind of help illustrate how this all works and comes together, and to illustrate the variety of different workloads that you're going to start seeing in Hadoop 2.0 with Yarn and some of the other innovations, I want to take a look at a couple of examples here. First is proactive customer engagement. And this is an example from a retail bank. It could also be an insurance example. And what's going on here is the infrastructure is set up in a way so that you can recommend products and services based on personal preferences, based on market conditions, as we see these fix and swift type market data come into the picture, based on customer behavior, whether it's through social data or clickstream data, or even customer transaction data. You don't even see that on this slide, although it should be there. And the customer transaction data feeding into the data lake. All this information is feeding into the data lake so that you can start to make appropriate and next best action recommendations to increase sales, whether it's based on, like I said, customer behavior or maybe specific life events that are occurring within that customer, especially your customers that are of high net worth. So, maybe they just had a new member of the family. Maybe they got a new job. Maybe they bought a new home, or they're getting ready to retire or saving for college education. So all this information, including the clickstream behavior that they're doing when they research particular equities or make certain transactions or decisions or get new credit cards online if it's a retail bank, like I said, all this information can feed into the data lake. Whether you use it immediately or not, that's not so important. What's important is now I can store this massively at scale, and when I'm ready to ask the question, what if this or what if that, I can do that. And so what you're seeing here is a different variety of technologies and workloads interacting with the data lake. We saw some of these technologies in the logical data warehouse slide that Ahmad had pointed out. So what we have here is batch processing of data going into the data lake or the logical data warehouse. We have streaming data from real-time data sources. We have a CEP engine for real-time event processing. And if you were to draw an imaginary line halfway through this slide, and imagine the bottom part is more batch-oriented and the top part is more a real-time channel, then what's really going on here is the batch channel is identifying patterns and trends and things like that. And the real-time channel is enabling you to respond and react to both threats and opportunities in real time as they correlate those events with what's been seen in the logical data warehouse or the data lake. And also notice master data is a very important consideration here because in order to do interesting joins and analysis on particular demographics or segments of your population, you need a single version of truth that feeds into the lake, but at the same time, it's bidirectional. So everything that you're deriving from the lake in terms of insights and profiles can be used to enrich the master data. And this allows, in this case, financial advisors to have a 360 view of the customer and interact with the customer in their best interest, or to automate a telephone or a text message to the customer so that they're made aware of certain opportunities. Now, the next example, advanced one too many. The next example looks quite similar, right? But this is a healthcare example. It's proactive patient member engagement for a healthcare insurance provider. And in this case, we're bringing in different types of data, but using similar workloads, similar infrastructure, and similar architecture. So what I'd like you to get out of this is that you can build a common modern data infrastructure that includes Hadoop 2.0 with Yarn, that includes a Teradata data warehouse and data marts and relational databases and infrastructure to it, and then use the data platform that Informatica provides to do the streaming and the data collection and the integration and the cleansing and the event-based processing and MDM to deliver. In this case, what we're seeing is we're monitoring patient data coming from ambulatory monitors. We're bringing in clickstream data from patients or their families doing research online or talking within patient forums. We're bringing in social signals in terms of maybe particular conditions or activities of the patients, or sometimes family members often tweet about their patients. And all that goes into the lake. Once again, whether we use it all or not is not of critical importance here, but it's there so that I can ask the interesting what-if questions. And as I develop and validate the models through data science algorithms and so on, then I can reduce the total cost of care. I can improve patient outcomes. I can do all these things that are important for a healthcare insurance provider. Now, what does this look like in terms of infrastructure? We've seen a couple of different diagrams and representations here. And our view of this is you have this unified data architecture that Ahmad had pointed out. Think of a logical data architecture for this persistent data storage and optimized processing engines based on data type, data volumes, a whole variety of different criteria that go into determining where the processing and storage should reside. But one thing that we do to help you optimize this across these different platforms is what we call our Vibe virtual data machine. So this enables you to build the data pipeline once. And what do I mean by the data pipeline? It's what you saw in the previous slides. It's basically integrating, accessing, cleansing, and matching the data, and then feeding that into the data field applications to do the proactive 360 customer analytics, to do the proactive patient member engagement, and then the top layer is what we refer to as a data intelligence layer. And that's where you start to really get interesting in applying machine learning to data sets itself. So making recommendations of data sets to the data scientists, inferring structure from new data sets that land in the data lake that you don't know what the structure is until it infers it for you and makes some recommendations. Gathering metadata and storing that in HCatalog and within the Hadoop system so that you can access that and find the data much more easily. Discovering sensitive data and other types of metadata. All this is what helps you build out that data intelligence layer. And what this looks like, if we drill down into the data lake architecture, is you have multiple data types off to the left. We're ingesting this into the data lake both through batch, through data replication and change data capture, through streaming, through data archiving. You need these different modalities to get data into the lake because data is being generated and created at different latencies. And so that's what we provide, is that ability to ingest at different latencies and different volumes. And then once it's in the lake, this is where we take advantage of Yarn because we're not necessarily beholden to MapReduce. We generate native MapReduce for parsing and ETL and cleansing and matching. But now we can also leverage Yarn to share some information between the nodes and to optimize the workloads even further. And as the Hadoop ecosystem evolves with Stinger and Tez, we can take advantage of those technologies also to further optimize the pipeline so that you don't have to go back and rebuild or refactor your code. And then we can get the data out of Hadoop, we can enrich the metadata, bring it into a data warehouse or data mart. So just to kind of emphasize once again that you can build the data pipeline once and optimize it to run on any of these different systems that we talked about earlier within the logical data warehouse. You have the data lake, you got data warehouses, you may have some data integration service, maybe you want to run things in the cloud. You can build it once and you can deploy it on each of these platforms. Once again, what that enables you to do is as new innovations occur within the Hadoop community, whether it's Yarn or Stinger or Tez, you don't have to go back and rebuild your data pipeline. You'll automatically inherit that using Informatica in this case. One of the key advantages to taking this approach, as opposed to reinventing the wheel and hand-coding these data pipelines, is that it takes longer. It takes longer to build it. It takes longer to test it. And so using tools like Informatica or using tools within the ecosystem that are SQL-like in nature, this enables you to leverage existing skills so that you can be 5 times more productive. And at the same time, we're going to worry about the performance tuning and the optimization as opposed to you having to do that over and over and over again for each hand-coded and crafted ETL or data quality job. And then finally, the other key advantage here is that we often see companies struggle making the leap from the sandbox to the multiple projects and into the production center. John had mentioned earlier that you start off with one project and then that expands. In order to expand, you kind of have to avoid some of the traps. And some of the traps is that having to go back and refactor and recode some of what you built in the sandbox environment. As things change, it's less flexible. There's not as much reuse. There's less governance in terms of data lineage and metadata. And so by using this visual development environment, this metadata-driven development environment, you're able to make it the leap into the production stage much faster. So as a call to action, I would say that it's very easy for all of you to get started. You can simply download a variety of free trial versions. The first one is our free Informatica Big Data Edition, which automates the data pipeline that I just described for you. It's a pre-configured VM. It includes the Big Data Edition. It includes the one-node Hortonworks cluster, all ready to go. You can also download the Hortonworks Sandbox, and that's really the fastest way to learn Hadoop. And you can also download Teradata Express and Aster Express. Those are also pre-configured virtual machines that are ready to run with full functionality of Teradata. And with that, I'd like to turn it over to Tim for the Q&A.
Great. Thank you all. Great presentation. We're a little bit lacking on time for the Q&A, and I want to make sure I try to get a question in for each of you for those that came in. During the Q&A portion, I want to make sure everybody sees the current slide. It provides the contact email for John Kreisa, John Haddad, and MapReduce. Please take it down so that you can ask them specific questions or comments later on. So the first question I'm going to ask for John Kreisa. John, what's the most common use case for Hadoop?
That's a great question, Tim. Thanks, and thanks for those who asked it. We see Hadoop, of course, across a very broad set of use cases. I would say that for some level of data processing, data transformation would be the kind of most common use case. They're using it as a complementary tool to the to some of their other pieces of infrastructure. But really, in the end of the day, for a lot of this, data that is coming in from web logs and from machine-generated data, it often just needs to be processed in some way at scale. And Hadoop provides a great infrastructure for processing and transforming the data. Whether you're initiating that transformation from your Informatica Power Center interface or maybe through something like QueryGrid from Teradata, it gives you multiple ways to interact with that data and perform some of those transformations. But I'd say transformation of data at scale would be the number one use case we see.
Great. Thanks, John. And while you're on the floor, I want to ask, a couple of folks were asking for a little more information about Yarn, how it all ties together. Do you have any sources for detail, sources for them to get additional information about Yarn that you would suggest?
Sure, Tim. Thanks. Yeah, great question. So, absolutely, we touched just a little bit on the value of Yarn in terms of enabling a data lake and multiple workloads, batch, interactive, and real time. If you want to get more information, there's a tremendous amount of information on Yarn, white papers, web pages, videos, blogs on hortonworks.com/yarn, Y-A-R-N, and that will take you to a page which gives you initial definitions, and then points you to a tremendous number of resources that you can learn from Hortonworks about how Yarn has really transformed Hadoop as a platform. Okay,
excellent. Thanks for that. Imad, this question is for you. Why do I need a logical data warehouse?
So the answer to that, why do you need a logical data warehouse? It really comes back to that unprecedented growth that we've seen both in data volumes, data variety, and different types of data and different analysis. Having one technology to address all of these needs in the market, I think, is unreasonable and just not not doable. And so you need these different technologies all coming together and working together so that companies can meet their needs in terms of analytics and the different types of data, analytics, and user expectations. So I think you need that variety of tools.
Okay, very good. So John Haddad, this question is for you. Can you go into some detail in terms of how the Vibe virtual data machine works?
Yeah. So the way the Vibe virtual data machine works is it creates a loose coupling and abstraction layer between the underlying deployment systems. So everything you define in your data pipeline is specific to the data itself. It has nothing to do with the underlying deployment. That is handled through configuration. So in other alternative ways of approaching this, what happens is you're specifically tied to Pig or Hive or MapReduce or some of the underlying technologies, or you're specifically tied to an underlying technology within one of the traditional systems. We've abstracted that and separated out completely the design from the deployment. And we've done this for the last 20 years. This has been an underlying design philosophy at Informatica. And this is what enables you to take advantage of each of the different storage and processing engines available within the modern data architecture without having to go back and refactor and recode. So I think there was also some other questions related to performance. So this is very intricately tied into how we optimize for performance too, is by distributing the execution through the Vibe engine to the appropriate engine, we're architecting everything we do on that platform specific to that platform. So for example, in the case of Hadoop, how do I get better performance on Hadoop as opposed to, say, Pig or hand coding it? Well, the way is quite simple. What we do is we have a couple of different levels of optimization. The first level of optimization is we basically take that entire pipeline, we rearrange it to put certain transforms before others that we feel are more appropriate. And then what we do is we optimize not only the entire pipeline end to end, but also the endpoints in terms of getting the data into and out of. So a couple of examples where we compared and benchmarked ourselves against Pig development was we found that in some cases, we're up to 3 times faster as a result of that. We've performance-tuned each of these pre-built transforms, hundreds of pre-built transforms, over many different implementations, as opposed to someone that's hand-coding this has to go through that all themselves. So you're leveraging hundreds and hundreds of man-hours for each of these transforms and the entire pipeline being optimized on that system.
Okay, very good. Thanks for tying in that second question as well. In line with that, there's some questions that you briefly mentioned a moment ago compared to Pig. Can you go into some additional details there as well?
Is the question a bit more specific, or is it just kind of general?
Vibe might be producing MapReduce job internally. How does it scale on performance and other features compared to Pig?
Yes. Okay. So everything we're doing is generating native MapReduce to be executed. Of course, Pig will eventually do the same thing. But like I said, typically when someone's coding in Pig, they're doing a portion of the pipeline, and they may not be thinking through the complete pipeline end to end. And even if they do, like I said earlier, there's a lot of performance tuning that has to go into that in order to make it execute as efficiently as possible. And so what we've done is not only have we optimized each of the transforms, but when you push that down and run that on Hadoop, we're looking at the full picture and moving things around and optimizing the entire flow. And that way we're not limited to any Pig constructs. We can do eventually anything we want, and we're not even beholden to the MapReduce paradigm, and this is where Yarn comes in too.
Okay, thanks for that. Unfortunately, I'm going to have that be the last question. Thank you to the audience for some great questions, and again, take down everybody's information here. You can reach out to them directly, and I want to make sure that everybody is assured that all questions are going to be sent to the panelists today, and they will be answering them directly to you so that your question does not go into the ether. I just have a few quick announcements to make. Please mark your calendar for September 30th in our next Data Science Central webinar, Using Data Science Techniques for our Automatic Cluster of IT Infrastructure Alerts, sponsored by Pivotal. This brings our webinar to a close. I want to thank Teradata, Hortonworks, and Informatica for their sponsorship, and our panelists for their insight into today's topic. I look forward to seeing you all again on our next webinar on September 30th. Good day.